Canola School on RealAgriculture.com is brought to you by Alberta Canola Producers Commission, SAS Canola, and Manitoba Canola Growers.
Kelvin Hepner with Real Agriculture, and we are pleased to be joined by Dr. Brianne Tideman with Agriculture and Agri-Food Canada, a weed scientist based at Lacombe. And Brianne, you've been doing extensive research. We actually caught up with you back in summer on your mechanical weed control and weed seed destruction research, I guess. Where are things at in terms of what you learned in 2017 and where this could fit in Canada?
Okay, so we actually had our first field season in 2017 with the Harrington Seed Destructor. We were able to get it out into 20 producer fields and actually put out harvest trials in 20 producer fields. We were successful in all of them, comparing the seed destructor to a non-seed destructor treatment. And so we're looking at weed population control. What we'll do is we'll be back in those same fields for the next 2 harvests as well, the exact same spot, exact same area where there was weeds, so that we can look at how we affect those populations with the seed destructor compared to without it. And so we don't have any data yet in terms of the weed population effects, but we did learn a lot of lessons. The first one being that air velocity is really key with some of these machines, so you have to get your chaff off of your sieves and somehow up and into that seed destructor input, and that takes a lot of air velocity. If you don't have air velocity, you end up with a plug. If you don't catch the plug in time, you end up with burnt belts, and then it's just not a good situation. So making sure you have the air velocity, we did have to make adaptations in terms of our pulley size with our belts on the blower so that we had enough air velocity to move that around. Green material makes it that much worse. If it's green or if it's tough, it just doesn't flow as well. And I mean, we see that normally with producers harvesting. When it's tough, you can hear it in the combine that it's working that much harder to process. Same thing with the seed destructor. Again, it can lead to blocks, belt issues, things like that. The other one that we found is that the toe-behind implement, it really doesn't have a great fit in Western Canada. We're too hilly. We're just not long enough and flat enough without having to turn, and you run into issues there. So you can get impacts with, the bypasses between the tubes going into the input, things like that. So the integrated units are going to make a lot more sense here. We just didn't have access to one of those to test. And with the process to get some of those implements, it was easier to test what we had that we know is about equivalent to at least the integrated seed destructor unit. And at some point in time, we'll have to look at something like the seed terminator as well.
Okay. Those are both newer models. The integrated one is Harrington Seed Destructor that's actually attached to the back of the combine?
Yeah, so the integrated Harrington Seed Destructor, it uses the same type of mill as what was on the toe-behind unit, but it's actually built into the combine. So there's 2 mills that sit right on the back of the combine that the chaff flows through. The seed terminator is competition to the integrated seed destructor. It's also built into the combine, but it's a slightly different type of mill using a multi-stage hammer mill instead. So new prototypes, new developments in the technology. The toe-behind seed destructor was never intended as the final product because there was a realization that producers don't want to pull these kinds of machines. It's a lot more efficient for it to just be built in, and that's where we're moving to now.
Okay. You mentioned dust is something that you have to deal with as well when you're working with this, of course?
Yes, particularly if you're working with it inside a building of any kind. Outside, there's a lot more air movement. It's not so bad. It's not as loud. You're not working as close to it. When you're doing the stationary work, there's a lot of fine dust produced, and it's very, very itchy. Mm-hmm. Yep.
Something that we might not think of from a research perspective, but from a practical perspective if it gets used on a farm.
Yeah.
The key, I guess, is that you need weeds and the weed seeds to enter the combine, right? For this to be effective?
Yeah, absolutely. So in order for it to be effective, you actually have to have the weed seeds in the chaff. So they've got to still be on the plant when you go through at harvest time instead of on the ground, and they've got to be produced high enough in the canopy that you can get them in the combine. If you think about something like chickweed, which is really low growing, producers are tending not to cut that low. They don't cut at ground level because there's a big risk to damage to their equipment. And so we're cutting above that level. That means you can't get those seeds in the combine. Tumbleweeds can also present a problem. Depending on what stage they're at when you cut them, because of the shape they are, they can tumble up and over and off the header and also give you issues that way. So.
We also have this weed called wild oats.
We do have a weed called wild oats. And the problem with wild oats is, as many producers know, it starts dropping its seeds fairly early in the season. And that presents a problem for our ability to get it in the combine. We're doing some additional research on that, looking at earlier maturing crops, comparing swathing to straight cutting, things like that, trying to see if we can optimize the amount of wild oats we can get. But wild oats will be a challenge. Now, having said that, there's a lot of other weeds that are also challenging that will make very good fits, things like cleavers, where group 2 resistance is really starting to be an issue in the pulses. Cleavers look like they're going to be a good fit with the seed destructor. Volunteer canola. It's a big one. We grow a lot of canola. There's canola coming out the back of the combine. There's canola in other Roundup Ready crops like soybeans. And so managing the volunteer canola looks like it'll be a very good fit as well.
Okay. So where do you see this in terms of the potential right now? I know we're still in the early stages of this research and in terms of any adoption happening in Western Canada. Where do you see this going in the long run, or where do you see it fitting?
What we're really hoping is that we'll be able to provide answers to producers when they get in a situation where maybe their herbicides aren't working anymore. So with wild oats as an example, there's a population that we know of in Western Canada that is resistant to 5 different herbicide groups. So what are producers supposed to do? And so we're trying to find some of those answers before they necessarily need them, so that when they come to us for the answer, we actually have them. The seed destructor, or those types of the crushing, grinding implements, seed terminator, integrated seed destructor, I think they have the best fit in terms of harvest weed seed control. It looks like things that could be easily used in our system. We're going to be looking at other methods as well, and hoping that producers will find something that fits with what they're dealing with.
All right. Well, we'll follow where the research goes. Thanks for taking the time to chat with us again, Brianne.
Yeah, thanks a lot.